friends, welcome to the session. In this session, we'll be discussing one of the important network theorem called as the Norton's theorem. In this session, we will see how it is possible to convert a complex circuit into a simple equivalent circuit which consists of a current source instead of a voltage source and a parallel resistance called as the Norton resistance. So many times when we have been provided with complex circuit and whenever we have been asked to analyze the circuit, then instead of converting the given circuit into the equivalent voltage source and series resistance as we do in case of Thevenin theorem, it is essential to convert it into a current source instead of a voltage source. So in this session, we will see how the Norton theorem can be applied to any given circuit so that we can obtain its Norton equivalent circuit. So friends, as you know that we are recording this session by using the iPad and we are making the use of suitable softwares. So let us go for the discussion of the Norton theorem. Norton theorem states that if there is any complex circuit, if there is any complex electrical circuit, then that circuit can be converted into equivalent Norton circuit, So it is possible that whenever we have been provided with any complex circuit, then that circuit can be converted into equivalent Norton circuit. For example, suppose we have a complex circuit, then this circuit can be converted into a current source along with a parallel resistance. So such type of the conversion is possible by making the use of the Norton theorem. So any complex circuit can be converted into such type of the Norton equivalent circuit. So how it is possible to convert the given circuit into the Norton equivalent circuit? So there are certain steps that we need to follow. So the first step is that you need to decide where you have to apply the Norton theorem. So select the terminals where you need to apply the Norton theorem. So normally the selection of the terminal will depend upon where you want to determine voltage or current in the circuit. And once you have selected those terminals, then you need to short across the terminals. That is, if there is some resistance present between the terminals, you have to remove that resistance or you have to short that resistance. In the second step, we can find the Norton current. The Norton current, that normally we write it as IN. Then in the third step, we will remove the short, we will remove the battery, we will remove the short, and also there is some battery present in the circuit, we will remove the battery also. And then we will calculate the Norton resistance, and for the Norton resistance we use the terminology Rn. So we will remove the battery, that is we will short the battery, and we will remove the short across the terminals that are being selected by us, and then we will calculate the Norton resistance. And then in the final step we will obtain the Norton equivalent circuit. the Norton equivalent circuit. So Norton equivalent circuit will consist of a current source followed by a parallel resistance. So let us understand how these steps can be applied in order to obtain the Norton equivalent. So we will consider one circuit. Suppose we have been provided with a circuit like this, a simple circuit we will consider. Suppose this is a 6-volt battery. Suppose this is a 2 ohm resistance. This is another 2 ohm resistance. And this is another 2 ohm resistance. And suppose I want to determine the value of the current flowing through this load resistance, 2 ohm resistance. So in the first step, what we will do, suppose these are our terminals A and B, to which we have to apply the Norton theorem. So I will convert this circuit into like this. And I will make them short. So this terminal A and B will be short circuited. This is 2 ohm resistance and this is 6-volt battery. And suppose this current which is being flowing, we call it as ISC, or sometimes it is called as IN. So initially we can calculate the value of the current I flowing in the circuit. So I will be equal to battery 6 volt. Now this 2 ohm resistance and this 2 ohm resistance will be in parallel with each other. Therefore, their effective resistance will be 1 ohm. So 2 plus 1, the effective resistance is 2 plus 2 parallel 2. That is, it will be 3 ohm resistance. Therefore, 6 divided by 3. So I will get this current as 2 ampere. Out of this 2 ampere current, some part will flow as an ISC. Therefore, I can calculate IN, which is equal to ISC, which is equal to 2 into 2 divided by 2 plus 2, that is 4. So it is just nothing but 1 ampere. So the amount of 1 ampere will flow through the terminals A and B. Now, in the second step, what we will do is that we will remove the battery, we will short circuit the battery. And now our circuit will look like this. We will remove the short circuit across the terminals A and B. So I can find out the value of Norton resistance. So this Norton resistance we will write it as Rn, which is equal to 2. This 2 and this 2 ohm resistance will be parallel in each other. Therefore 2 parallel 2 plus 2. So this is just nothing but a 1 plus 2, that is 3 ohm resistance. So now finally I can apply, or I can get the Norton circuit where I will have a source IN as 1 ampere and this Norton resistance will be of 3 ohm, and then I will connect now between the terminals A and B the resistance that was present initially in the circuit, so that I can calculate the value of IL. So IL can be calculated as 1 into the resistance will be 3 ohm and the net resistance will be 3 plus 2, that is 5, and therefore we can say that this current will be 0.6 ampere. So by making the use of the Norton theorem, it was possible for us to determine the value of load current IL flowing through the load resistance of 2 ohms. We can easily calculate it. So whenever one has to apply the Norton theorem, then one has to remember these steps. You have to initially select the terminals for which you want to determine the current or voltage, short these terminals, find IN, then remove the short, remove the battery to 0, find Rn, Norton resistance, and then finally you can obtain the Norton equivalent circuit. So these steps one need to follow in order to obtain the Norton equivalent of any given complex circuit.